Thank you so much. I hope you guys are doing well. So I will discuss some real life example for using your human intelligence to process your problem in your life and provide solution for that. Like for example, you want to drive on a road. So there are some rules for that. Okay, so you are following that rule and you successfully travel from place A to place B. So it's a kind of algorithm. You are following that algorithm and using your human intelligence, preparing a cake, brushing your teeth, and talking to your family members, discussing something with your family, try to convince your family member. We are using human intelligence for that to process a specific problem and provide solution for that. Like for example, you want to buy something from the superstore. So all these problems in your life, you are playing with them, and you have human intelligence. You are processing problem and creating solution for them. You're producing algorithm, and through that algorithm, you are providing solution, and you are solving your problem. So I hope you have achieved what I want to say. So you can use your human intelligence to process the computational problem. Like being a computer scientist, like I am working satellite image analysis. So I should use, like being a human, how I will react to that problem. So being a human, you can use your logic. You can use your logic, and you can replicate your logic, and you can produce algorithm for that problems, and you can replicate your human intelligence in your real life. So what I told you, that I will discuss the PageRank algorithm, how the Google search work, and for what purpose the Google was introduced, and now you can see everywhere is Google. So actually this PageRank algorithm was designed by two PhD students, and it tries to, the PageRank algorithm tries to find what you want to search and go on World Wide Web, on internet. So actually there are millions of websites, what you want to search. Like for example, if you compare the Google with the Bing, so you will understand, or Baidu in China, you will understand that if, like for example, if because it's mostly the Baidu and Bing are mostly depend on Chinese language. So if, for example, if you want to search something in Chinese in Baidu, okay, so it will react friendly. And I'm just doing comparative analysis between Google and Baidu upon the different languages. So if I search in English, so their result will not be that much good as compared to Google. And so it's the PageRank algorithm through which we can easily search about what we want to search in Google, what we want to search in internet. So that's also an algorithm. So essential characteristics of algorithm, essential features of algorithms. So it should be user friendly. Like for example, if you want to design a mobile application, so if it's not user friendly, so you cannot get what you want to achieve in Google Play or in different libraries. You want to achieve what you like clicks and download and something like that. So you cannot achieve such thing because it's not user friendly. So your algorithm should be user friendly, and it should be correct. Correctness, again I am discussing that correctness is we can use correctness in two scenarios. Like in conventional programming, like for example, if you have an algorithm for sorting, so correctness is very important. Correctness is very important. 100% correctness is very important. But if you are working in a machine learning or deep learning algorithm, then accuracy, you can get accuracy in percentage. So 100% correctness is not that important. Correctness in the sense of, I mean that correctness in the sense of what you get the result. Like for example, if your algorithm, you give some list, a random list to algorithm, and it search that list for you. So it should be correct. But if you are using a machine learning algorithm, that you will have to focus the specific accuracy that you got 50% accuracy and 30% accuracy. Like in weather forecasting, you mostly see that sometimes there is prediction of rain, but still sometimes their accuracy is not that really good. So in machine learning and deep learning, we are focusing accuracy, but in percentage. But in conventional algorithm, we need to have 100% accuracy. So your algorithm should be efficient. Extensibility, maintainability, and scalability. These 3 points are quite connected with each other. Extensibility means that if you want to add some more feature to the existing algorithm, you can easily add. Your algorithm should have some extensibility features, like it should be extendable. Okay, it should be extendable. You can add some more feature to that. Okay, like for example, you're using mobile, Android mobile or iPhone. So some features, few features added to your existing operating system. So it doesn't mean that they replace the operating system, but it's added some more feature to them. So this is the extensibility. Maintainability mean that your algorithm should be maintainable. Like for example, you have a sorting algorithm, and it can, like right now in 2019, you think that okay, I have only 1 million record. Okay, like you design for 1 million record, and in 2020 you have 2 million, 3 million data. So element. So your algorithm should be maintainable and should be like if it crashes, so you can maintain that algorithm, and you can repair that algorithm, and you can maintain. So the third one is scalability. Scalability means that like we can increase the volume and the coverage. Actually, you can say it's a coverage of your algorithm. Like for example, if you have 1 million, your algorithm is for 1 million record, so it can be extended for the 2 millions to process the data. Like 2 million items, it can process 3 million, 5 million, so something like that. So your algorithm should be scalable. It should be scalable. So this is the main difference between extensibility and scalability. And maintenance, you can say that maintenance, most of the things, like if, for example, if you buy mobile or a car, so you can insure that, and it provide you maintenance. So it's a kind of you can apply this example on that. So cost is also very important. And for example, if you design algorithms, so you need to focus on hardware and software both. You need both hardware and software. Like for example, if I am working in remote sensing or object detection, so I need to have a specific system for that. I need to have GPU for that. So this is the hardware, and I need to have some TensorFlow, YOLO V5, and I need to have these libraries also. So both the things are very important. So I have already discussed user-friendly, correctness I discussed in detail, and efficient also I have discussed. So in the next lecture, inshallah, we will discuss the student ability prediction, like how we can predict the student ability. Thank you so much. I hope you have enjoyed today. If you have any question, you are always welcome in the comment section.